Hello and welcome to today's video lesson about function shifting. This is the fifth of 5 videos where in this video we're going to put together all the things we learned in the other videos. So here are the types of shifts we looked at. In the first video we looked at vertical shifts, where you make your new function, y is your new function name, g of x, k of x, whatever it was, but your new function is now your old function's y values plus a number. So g of x equals f of x plus c, g of x equals f of x minus c. And this raises the graph up and down. Up if it's plus, down if it's minus. Now the difference between vertical shifts and horizontal shifts is the constant was added outside of what we call the argument of the function. It's not linked with the independent variable. It's not part of what is in parentheses in the function identification. It is after you figure out a y value, you now add a number to it. Here with horizontal shifts, the addition and subtraction is grouped with the x. So this will change x coordinates because it's grouped with the x, and it changes them in the exactly opposite way you would think. X plus c shifts the graph left c units. X minus c shifts the graph right c units. If I put a negative sign out in front of the entire function, I change the sign of all the y coordinates, which will reflect it over the x-axis. Everything that was above will become below the x-axis. Everything that was below will become above. But if I put this negative in front of the x, now I'm changing the sign on the x coordinates, which will make everything that was on the right of the graph go to the left and everything on the left go to the right, or it will be a reflection about the y-axis. So didn't mean to do those marks, so let's get rid of them. Here, when I put a number in front and multiply, now I'm not adding. If this was c plus f of x, it would be the same as what was on the top of this chart. But it's c times f of x. If c is a number bigger than 1, well, in either case, you're going to multiply each y coordinate by c. If c is bigger than 1, it has the effect of making the graph grow vertically. The numbers that are positive become bigger and positive. The numbers that are negative become bigger and negative. It stretches the graph vertically. Each y coordinate is multiplied by c. If c is between 0 and 1, you're actually going to end up shrinking, because when you multiply a y value by a number like a half or a third, you actually make that y value smaller. If instead I put the c inside the argument of the function with the x, I'm going to change the horizontal coordinates, which will change how the function looks horizontally. It will be stretched or compressed, and I divide each horizontal component, or the x coordinate, by c. I divide because it's with the x, so you do the opposite of what it looks like you would want to do. So if this number c is bigger than 1, what I used to have at x is some number, I now have at x is a bigger number, and has the effect of stretching the graph left and right. But if c is like a half, between 0 and 1, if I multiply what I used to graph at x is 2, I'm now going to graph at x is 1. It's going to have the effect of compressing the graph. So that's a summary of the different function shifts we looked at. And we looked at this function a lot. We used this x minus 1 squared times x plus 3, and here is its graph. Should be familiar by now. And here are some of the important points. So what if that is our function and we do this to it? There are multiple steps here. I've got a c times an x, I've got a negative in front of the f of x, and I've got to choose subtracted. Well, you know what each of these things does individually, but putting them together can be tricky. So what you need to do is do the 0.5x first. Work as if this were an order of operations problem. Take each x coordinate and divide it by 0.5. So you had these points in the original function. These were the important points that were listed. Negative 3, 0. Negative 1.79.5. That was that relative max. We had 0, 3. And then we had 1, 0. So to get f of 0.5x, you're going to divide each x-coordinate by 0.5, which has the effect of doubling it. I'll have negative 6, 0. I will have negative 3.4, 9.5. I will have doubling 0 is still 0, so there's still 0, 3, and 2, 0. So I've taken care of this piece. Now I need the negative of the y values. So f of 0.5x, the negative of that is, I'm just going to change the sign on all these y values. Well, the sign of the first point, 0, is still 0. Negative 3.4, negative 9.5. Negative 0, 0, negative 3. I'm changing the y coordinates. And 2, 0. So now I've taken care of this part of the function. Now I need to subtract 2. So the final function is going to be in this column here. I'm going to subtract 2 from each of the y coordinates because that's outside of the function argument. Negative 6, negative 2. Negative 3.4, negative 11.5. 0, negative 5. 2, negative 2. So let's take a look at our new function that is already graphed here and see. So let's see. There's the point 2, negative 2. Each one of these is lines is 2 grids. 0, negative 5 will be right there. So what I could do if I were trying to graph this is I could do this step-by-step, point-by-point process, and then I would have some points to sketch and get some idea of the shape because it's going to be somewhat similar to the original shape, but I would at least know where to put my graph. So negative 6, negative 2 is right there. Negative 3.4, negative 11.5. That's going to be a little trickier to figure out. But so that's 2, that's 4, 3.4 would be built there. It'd be in here somewhere. A little trickier to graph. But you can see that this process, and if I used more points, I would fill in more points, shows me points on the graph. So again, what I did was, let me erase these marks so you can see what the original function was, or the original question was. Here we go. The original question said, do negative f of 0.5x minus 2. If I were following order of operations, there are no exponents, but I would look at grouping symbols first. So I would look at the grouping symbol here. I have a parenthesis, so I would do this first. Pretend that's my only shift. F of 0.5x means I divide each x coordinate by 0.5, and I write down the results of that. Then I look, what would I do next? Well, next you move outside here, and this is a multiplication. This is negative 1 times this. So I do this left to right. I would do multiplication before I did the subtraction. So now I'm going to multiply every y coordinate by negative 1, and that's what I did here. And then finally, I subtract 2. Well, this subtracting 2 is outside of the function argument, so it controls the y coordinate. So I subtract 2 from each y coordinate. And these are my final points on my function. So you work this by order of operations. That's how you know what to do first. So take it a step at a time. Start inside the parentheses first. All right, let's go to another example with our other function. And I had written all this out here. But I thought it would be better to show you where it came from. So here's our function f of x. You've seen this before. Here, every grid line is worth 1. And now I want f of x minus 2 plus 5. So the first thing I'm going to do is f of x minus 2. I'm going to do the x minus 2 part first. This moves 2 to the right. The whole function is going to move 2 to the right. So I'm going to do some temporary points here. I'll do them in green, I guess. I'm going to move the function 2 to the right. Each one of these is worth 1, so that point goes there. That point goes there. That point goes there. 2 to the right. The height stays the same. I'm just moving over 2 to the right. This one, this goes 2 to the right there. This goes 2 to the right there. and this one goes 2 to the right there. So that's my first step. This just represents the f of x minus 2. That's all I've done in the green there. So the rest of mine, let me find the problem, was now I wanted to do a plus 5. That means I'm going to go up 5. So I'm going to take each of those points I did in green, and I'm going to move them up 5. So I'm going to pick a new color here, hopefully. I don't think it's letting me pick a new color. There it is. New color? No, that's right. There we go, new color. So I've moved f of x minus 2 to the right. Now I need to go up 5. Okay, so I'm going to move this green one up 5. 1, 2, 3, 4, 5. And this is going to be a point on my final function. And then I shifted to the right, then I'm going to move up 5. 1, 2, 3, 4. I should just go to 5 because that was at 0. And then this bottom point was over here. So I got to go up 5 from negative 3, so that'll put me at 2. Here I got to go up 5 from negative 1, that'll put me at 4. I got to go up 5 from positive 1, that'll put me at 6. I got to go up 5 from positive 2, that'll put me at 7, and that'll put me at 7. So my function is now this. I did the horizontal shift, and then I did the vertical shift, work from the inside out. Now, somebody is going to ask me, couldn't you have just shifted it up first and then moved it over? Yes, this is the one case where, which order you do doesn't matter, but once you start multiplying either the function itself or the x value, you must work from the inside out. So just be in the habit of working from the inside out. Do the x minus 2 first and then do the plus 5, because order of operations would say you do what's in the parentheses first, and then you would go back and look, is there any multiplication? No, there isn't. Then you would look at addition or subtraction. I have addition. So that is how you would graph this function, which has a multiple step shift or transformation, we would call it. So there's a couple of these for you to practice. I think there's 2. Yes, I gave you 2 to practice. And I want you to try these, shut the video off, try these, and then come back. All right, so this first one, g of x is negative 2 f of x plus 1. So I haven't done anything in the parentheses, so I don't do that. So I do negative 2 times all the y values here first. So I'm going to do a negative 2 times a 3 and get a negative 6 for this y value. I'm not doing anything to the horizontal here. So that one becomes there. Negative 2 times 0, remember we're looking at the y values, is still 0. Negative 2 times negative 3 is going to become a positive 6. And negative 2 times a negative 1 is going to become a positive 2. Negative 2 times a 0 is still a 0. I'm looking at the y coordinates here. Negative 2 times a positive 2 becomes a negative 4. And that 2 will also be a negative 4. So that's not my final function. That just took care of the negative 2. My final function needs to do that, and then I need to add 1 to each of the y coordinates. So I look at these red points I've drawn, and I just move them all up 1. So I've got that. I've got that. I've got one way up here. That, and that. And now these are the points I connect. And it was important that I did the negative 2 out in front first here. Order of operations really does matter. So you get a function that looks like that, and this would be that big closed circle for the function. The other dots are just points. So that is how you would do this one. Now, if you did that well, good. You're really getting it. Let's try the next one. The next one, we've seen this function before. We did this before, and that's why this graph is really that same piecewise function, only with the scale changed. So I want to do f of 0.5x first and then subtract 3. So I need to divide each x coordinate by 0.5, which has the effect of doubling them. So I look at the x coordinate of this point. It is a negative 8, because now each of these grids is worth 2. negative 8 divided by 0.5 is negative 16. This is 2, 4, 5. Negative 5 divided by 0.5 is negative 10. This is 2. Negative 2 divided by 0.5 is 4. Is negative 4, sorry. 0 divided by, the x-coordinate here is 0. This one is going to stay there. And then this is a 1. When I divide that by a 0.5, I get a 2. This is a 3. When I divide that by a 0.5, I get a 6. And this is a 5. When I divide that by a 0.5, I get a 10. I'm not done yet, though, because that is just this piece of it. I need to go and do this piece of it now. Subtract the 3. Oh, I thought I picked a different color pen. I did not. Now I have a different color. We're going to subtract the 3 now. Now this 3 is not grouped with the x, so it controls the up and down. It controls the y coordinate. So each of these points is going to move down 3. And remember, these grids are each worth 2, so I go down 2, 3. And then I go down 2, 3. And then I go down there. And down there, 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 and there. And I connect these dots. Now, could you have gone and done that in one step? Quite possibly you could have. Could you have just made a if you'd rather than do a step at a time, you want to make a list of your original points and then do the transformation a step at a time to each point like I did back here. You can also do that. So if you got both of those, you're well on your way to understanding this, and it'll just take a little more practice, like in the homework and looking at some more examples. All right, that's all I have for our videos on function shifting. Thank you for joining me.